welcome to the course EE8005 Special Electrical Machines. So here we will be seeing the power semiconductor switching circuits for switch reluctance motor. Okay. So at the end of this course, one can able to design the power semiconductor switches for the switch reluctance motor. Okay. So here the selection of the controller depends upon the applications. So one of the main aspects of the research in switch reluctance motor drives have been the converter design. The main objective of the design of the converter are performance of the drive and the cost of the drive. The power semiconductor switching circuits used are two power semiconductor switching devices, n plus 1 power semiconductor switching devices, phase winding user using bipolar OS. Okay, so at first we can see the two power semiconductor switching devices per phase and two diodes. Okay. So here you can able to see the diagram of two power semiconductor switching devices per phase and two diodes. As shown in the figure, the phase winding A is connected to the DC supply through power semiconductor switches T1 and T2. Depending upon the rotor position, when the phase A winding A is to be energized, devices T1 and T2 will be turned on. When phase winding is to be disconnected from the supply, the devices T1 and T2 are to be turned off. The stored energy in the phase winding A tends to maintain the current in the same direction. The current passes from the winding D1 and D2 to the supply, thus the stored energy is fed back to the mains. Similarly, phase winding B and C are also switched on the supply and switched off from the supply in a cyclic manner. This circuit requires two power switching devices and two diodes for each phase winding. For high speed operation, when required, the stored energy can be fed back to the mains within the available period. Usually the upper devices like T1, T3 and T5 are turned on and off from the signal obtained from the rotor position sensor. The duration of the conduction or angle of conduction data can be controlled by using suitable control circuitry. The lower devices are controlled from signals obtained from chopping frequency signal. The current in the phase winding is the result of logical and of the rotor position sensor and chopping frequency. As a result, it is possible to vary the effective phase current from a very low value to a high value for varying the following methods. By varying the duty cycle, we can control. By varying the conduction angle also, we can able to control. Next one, it will be the n plus 1 power semiconducting devices and n plus 1 diodes. So you can able to see the diagram. The circuit make use of less number of power switching devices compared to the previous one and diodes. When the switching devices T and T1 are turned on, phase winding A is energized from the DC supply. When these devices are turned off, the stored energy in the phase winding is fed back to the mains through diode D and D1. When devices T and T2 are turned on, the phase winding B is energized. When they are turned off, the stored energy in B phase winding C is switched on and off from the mains. The cycle will be getting repeated. This circuit makes use of n plus 1 power semiconductor devices and n plus 1 diodes where n is equal to the number of phases. So here the merits are the converter uses less number of switching devices, so free wheel during the chopping period. Voltage rating of the overall switching devices is very low. And demerits means disability to demagnetize a phase winding is very complex. At higher speeds, the outgoing phase cannot be de-energized. Next one, that is the phase winding using bipolar OS. When T1 is turned on the DC current passes through the phase winding A. When the device's T1 is turned off, the stored energy in the magnetic field is fed back to the DC source through the winding A dash and D1 to the supply. The three devices operate in a sequential way depending upon the signal obtained from the rotor position sensor and the chopping signals for PWM technique obtained from the controller. Okay. So here the merits are the converter uses less number of switching devices, so it allows fast demagnetization, and the demerits are suffers from double number of connections, a poor utilization of copper. So these are the two main disadvantages of the phase finding using bifilar wires. Okay, so that's all about this section. Thank you.